Hello YouTube. In this video we're going to be kind of exploring how to evaluate the limit of what we call a difference quotient, which is it's actually something we see quite often in calculus when we determine what we call the derivative. Okay, and so I'm just going to jump right into this. What would this limit look like of a difference quotient? We say for the function given by f of x equals x squared minus 1. So we'd have some parabola that's been shifted down 1. What we want to do is find the value of this limit right here, where we say that we have h going to 0, and what the value of f of 3 plus h minus f of 3 all over h is. Okay, and so one thing I guess I want to mention here is this: just like with many of the limits we've been seeing, if we attempt to direct substitute this in, or at least the limit of this, we say the limit of this equals what we get when we directly plug things in. If we were to plug in a 0, we'd get f of 3 plus 0 minus f of 3, and this is all over h, which we plugged in 0 for. We would get essentially f of 3 minus itself, and this is all over 0, which we get 0 over 0. So it doesn't help that we end up with indeterminate form, so there's got to be kind of a way to work around this. So the way is going to be this. Actually, we say, well, if I need to evaluate this limit, perhaps then what we need to find first is f of 3 plus h and f of 3, seeing as how I do have the function. Okay, and that's the recommendation that I make here. So we know that if f of x is actually equal to our squaring function subtracting 1 off of that, then we say, well, let's go find off to the side. This is always what should be done. F of 3 plus h and f of 3, since we need these values anyways. So for instance, f of 3 plus h, if I were to plug that in everywhere I see an x, I would end up with this statement right here, 3 plus h going in. And then f of 3, of course, would be, well, everywhere I see an x, I'm plugging in a 3. I only wrote out both of these because the second of the two is actually the easiest to evaluate here. We have 9 minus 1 is equal to 8. We are going to put this in our back pockets and not lose it because we need that for this part of our difference quotient. And then the other thing I want to find is the value of f of 3 plus h. So what I notice here is this. If I were to do this here, I'd have to FOIL out, or at least expand the binomial 3 plus h. And expanding this binomial, we get 3 plus h times itself. I was going to do a binomial expansion, but I'm not sure everybody that tunes into this is going to know how the heck I got my answer. So we say, all right, well, 3 times 3 is 9. We say 3 times h and 3 times h. We have 2 of those 3 times h's. So we'd say 6 total h's. And then we say plus h squared. But this would be the value of this quantity here. We still need to subtract 1 off of that. So we would get this. We would get, it seems to me, 9 plus 6h plus h squared. That minus 1, and combining like terms with this negative 1 and this 9 right here, we get a final value. God, sorry, I'll stick it down here. We would say this. I'm going to put it in a different order also. We say h squared plus 6h, and we say the positive 9 and a negative 1 give us a positive 8. And so this is actually the value of f of 3 plus h. So now we can actually eliminate some things here once we evaluate this limit. So we say, all right, well, we started off with the limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. It is still all over h. It's just that we now know f of 3 plus h. We've found that that is to be this value right here. So we have h squared plus 6h plus 8. And we were subtracting f of 3, which we also found. It was 8. So we say take away 8. And what I want everybody to notice is this. We still have a limit. We still have a limit. Can't direct substitute. That would give us undefined in the basement, or 0 over 0, even worse, indeterminate. But we do know this. On the top, the 8's gone. Okay, and so what this leaves us with is actually h squared plus 6h all over h. And what I also want to kind of point out is this. Now everything has a common factor of h. We could actually factor an h out of the top polynomial here. So we say the limit as h approaches 0 of this. We say h times h plus 6 all over h. And our h's cancel out. And so the lovely thing about this is actually we can evaluate this with direct substitution. We could say, let's just find the limit of h plus 6 as h goes to 0. And by the way, plugging in a 0 right here just gives us a 0 right there. And we say, well, 0 plus 6, it equals 6. Okay, so this is an example of how we use a difference quotient type of evaluation technique. Okay, but yeah, you do a lot of those. So my number one recommendation is this: if you're going to be finding stuff like this, I think what we want to be doing is this. Start by finding f of, say, in this instance, 3 plus h and f of 3, and then plugging in what you know, and then evaluating that limit, making sure you simplify along the way. Cheers.